All right, in this video, we're going to talk about 15.3 Objective 1. This will be our last video for this textbook. We'll apply basic dosage by body weight calculations to critical thinking exercises. Additional videos may be forthcoming for the playlist that talk about supplemental objectives and things not covered by the textbook. But this is pretty much the end of this playlist for now. So let's go ahead and get started. The pediatrician has ordered 4 milligrams per kilogram of this drug for a child that weighs 57 pounds, 2.2 pounds per kilogram. So that child weighs 25.90 kg, with the 90 repeating. You can round that to 91 if you want to. How many tablets are they going to administer? Well, the order was for 4 milligrams per kilogram. So let's multiply by 4. And so we have 103.63 repeating milligrams times, there's 400 milligrams in a tablet. And we get an answer of 0.2590 tablets. They tell us to round to the nearest tenth of a tablet. 3/10 of a tablet is the correct mathematical answer. I hope that doesn't make sense to you, because it doesn't make sense to me that we would be dispensing tablets here. Maybe we should consider contacting the prescriber for a different delivery method, such as an oral suspension, some kind of drops, injection, a different dose medication here. If we could contact the pharmacy and say, do you have this in something that's weaker? Could we figure out some way to administer this where we're not giving a silly answer like 3/10 of a tablet? Maybe you crush this up and put it inside of a capsule and weigh it out to give them exactly the right amount of milligrams here, or close to it. That's probably the least favorable option here, but that would be done in some cases. The reason you don't want to crush things up is because a lot of things are time released, and if you crush them, you mess up the time release in the medication. So yeah, there's just better options than trying to give somebody 3/10 of a tablet. That doesn't make a whole lot of sense. All right, the doctor orders morphine sulfate, 11 milligrams subcutaneously every 4 hours. It's needed for pain for a patient that weighs 71 pounds. Recommended maximum dosage for a child is 1/10 to 2/10 of a milligram per kilogram per dose. Morphine sulfate is available in 22 milligrams per 1 milliliter. So let's figure out if this is safe. Well, let's just figure out how they would dispense it first, and we'll figure out if it's safe. So 11 milligrams times, and then 1 milliliter is 22 milligrams, and 11 goes into 22 two times. Half a milliliter is 0.5 milliliters. Assuming that this is safe, and which we should not do, you'll see why in just a second, but assuming the doctor prescribed something safe for a pediatric patient, then we would give them half of a milliliter. But doctors sometimes forget that they're dealing with smaller or younger patients, and they accidentally write the adult dose, something like that. You're going to see something like that happen here, where they prescribe something too much. So 71 pounds for this child, 2.2 pounds per kilogram, 71 divided by 2.2 is going to be X is 32.27 repeating kg, meaning that our safe dosage range is somewhere between times 0.1 is 3.227 milligrams. Multiply this by 2 so that it would have been multiplied by 0.2 instead of 0.1. This is 6.45 repeating milligrams, and 11 milligrams you can see is, which was prescribed, is way bigger than 6.4, 6.5, right? So no, it's not safe. It's outside of therapeutic because it's too large. So the correct dose for this patient that weighs this many kilograms should be somewhere bigger than, let's see, to the nearest 10th, 1 decimal place, should be bigger than 3.2, smaller than 6.4. So we're looking at 3.3 to 6.4. I know my math lab is going to disagree with me and say that we should round this down to 3.2 and round this up to 6.5 and use regular rounding rules. No, don't do that, because to be safe, you need to be bigger than this low end. So you need to go up here no matter what this decimal value is. You need to go down here no matter what this decimal value is, so that you stay within this safe range. You can't use regular rounding rules and round too low to go outside the range or too high to go outside the range. So they're going to give the smallest answer that they can. They're going to say 3.2. I don't agree with that. I'm going to say 3.3 to 6.4. Anything between there should be the right answer. I'm just going to tell you they're going to say 3.2 because they're going to round down. But don't do that in real life, because you're giving somebody too little medicine if you go on the low end and round down below this lower boundary. 11 pounds, 2.2 pounds per 1 kilogram. 11 divided by 2.2 is exactly 5. Then we have 6 divided by 16 plus 18. It's going to give me 18.375 pounds. 2.2 pounds per 1 kilogram is 375. Divide by 2.2, and we get X is 8.35 when we round to the nearest hundredth. Is this statement true that weight in pounds is approximately half of the metric weight in kilograms? No. 1 kilogram is equal to 2.2 pounds. So that's not correct to say that. Amoxicillin pediatric drops are ordered for a child. The drug label says 20 to 40 milligrams per kilogram per day. The drug dose is 36 milligrams, and the available supply is 50 milligrams per milliliter. How many drops will the child be given? So nowhere are we told the weight of the child, right? So we just have to figure this out and say the order, assuming that we already figured out by the weight of the patient, is 36 milligrams. Our on hand is going to be 50 milligrams per 1 milliliter, which is 15 drops. Use our formula that this is 36 divided by 50 times 15. These are milligrams. These are milligrams. These are drops. So 36 divided by 50 times 15 is going to give us 10.8 drops. And we can't give a fraction of a drop like that, so we're going to have to say this is approximately 11 drops. Now we need to check this chart out here for a 7.5-year-old that weighs 55 pounds. So we're on this row because of age. We're also on that row because of weight. So we're good. We can use this chart to say we need to give 2 teaspoons, but they want an answer in milliliters. So we need to convert and say 1 teaspoon is 5 milliliters. 2 times 5 is 10 milliliters. And now let's read this last problem carefully. You'll see that they give you some extra information. So a nurse reads a medication chart, order Augmentin, 240 milligrams by mouth every 8 hours. That's what that means. The weight of the patient is 30 pounds. Augmentin is available for and 120 milligrams per teaspoon or per 5 milliliters. We want an answer in milliliters. So the weight here was irrelevant because nothing in the order said anything about per kilogram. We're not finding a safe dosage based off of kilograms. We're just figuring out how to dispense this 240 milligram dose, and we want the daily dosage. So we don't pay attention to the fact that this is every 8 hours. So this is going to be 720 milligrams per day. So, and 720 divided by 120 times 5 milliliters is going to give me 720 divided by 120 times 5 is 30 milliliters a day. You weren't asked this, but what would it be per dose? It would be 10 milliliters per dose. Each dose is every 8 hours. Okay, so that's it for this video, and that's it for all of our topics for this book. So good luck with your final that you probably have coming up after this. Good luck with, you should probably have some kind of practical exam for entering nursing school after this, your T's or your HESI or your NCLEX or whatever those are called that you're going to be taking. So good luck with that, and good luck in nursing school. Have a good night.